All right, so in section 2.5, we want to work with some more proofs today. We're going more to the geometric side. So let's take a look here. So on this proof, this is not currently set up the way that proofs are going to be set up for you, okay? Proofs are always going to give you something that is given, so a starting point, and they're going to tell you what to prove, okay? So I already know what the answer to this problem is. They ask us to solve for x. So I'm just going to go ahead and show you how this would usually be set up. So you would have something that says, prove, whoop, I'm sorry. We don't start with prove, we start with given. Given that the measure of angle AOM equals 2x plus 30. Well, how do I know that's given? It's in the diagram, right? And given that the measure of angle MOC equals x, prove x equals 50. Okay? That's how a two-column proof is going to be set up. They're going to give you some diagram to look at. They're going to give you some given information along with the diagram. You, of course, can always use the diagram, okay? But they're going to give you some known information, and then they're going to ask you to prove something, okay? We need to use deductive reasoning to come up to that conclusion, that same conclusion. Now remember, deductive reasoning means that we have to use postulates and definitions as breadcrumbs, as something to connect the dots, right? We know those two things, therefore we know this. And if we know that, therefore we know this. And so on and so forth. Okay? So, to set up our two-column proof, we need to actually have two columns. So go ahead and draw yourself two columns. I'm going to extend mine down here. Okay, and in your two-column proof, you should always label your two columns. The first one is your statements. Second one is your reasons. Okay, so in our two-column proof, what is always the first statement? The first statement is always your given. So we are given two pieces of information, so those go into my given blank. So my first statement, the measure of angle AOM equals 2x plus 30, and the measure of angle MOC equals x. Given. So then, next, we need to come up with some way of setting up an equation. Okay, some way of setting up an equation, because that's the whole point. To solve for x, we have to have an equation, right? Okay, so does anybody have any ideas of how we might go about setting up this equation? How are we going to write an equation to solve this? We could say, there's multiple different paths we could take on this proof, okay? We could say that the measure of angle AOM plus the measure of angle MOC equals the measure of angle AOC by our angle addition postulate. We could then say that we know the measure of angle AOC is 180 degrees because it's a straight angle, so the definition of a straight angle would tell us that. Right? We could do all that and then use substitution to write our equation. But you guys said linear pairs. We started talking about linear pairs. And if we're going to use linear pairs, we have to go a slightly different direction. Okay? The linear pair postulate says that if two angles are a linear pair, then they are supplementary. Correct? So I'm going to go ahead and in my proof state that I have linear pairs. Okay, some people might say that this is an extra step that you don't necessarily have to do it, but I would just identify that yes, we do have linear pairs. because that's something that we're using. We're using that knowledge, so we have to put it in our proof. Okay? So I'm going to say angle AOM and angle MOC are linear pairs. Now, quick question is, how do we know that they're linear pairs? Nope, not the linear pair postulate in this case. How do we know that they're linear pairs? How do we identify them as linear pairs? Assumption. Nope, not an assumption. Okay, but where are you getting that from? Why does that tell you that they're a linear pair? The answer to this question is easier than you guys are making it.
We don't know.
How do we even know what a linear pair is?
We were told.
It's not given. I was told you one day in a what? In a definition. I told you one day what they were in a definition. So we know that they're a linear pair because of the definition of linear pairs. Okay, that's how we know what linear pairs are, because there's a definition about linear pairs. Okay, so we now have information about each angle. We now have identified that those two angles are linear pairs. We can now set up an equation saying the measure of angle AOM plus the measure of angle MOC equals 180 degrees, and that is because we talked about the linear pair postulate. Good. The linear pair postulate tells us that linear pairs are supplementary. Excellent. Well, now, how do you suppose I'm going to solve for x? I have an equation, but I don't have x in that equation yet. I'm trying to help you guys. What am I going to do? I'm going to use substitution. I know the measure of angle AOM, it's 2x plus 30. I know the measure of angle MOC, it's x. So use substitution. So 2x plus 30 plus x equals 180. All right, so we used substitution. All right. Well, now it's very similar to what we were doing on Friday. So what's going to be my next step? Combine like terms. What do I get when I do that?
3x plus 30 equals 180.
Absolutely. Okay, step 6. To get x by itself, we do what? Subtract 30 from both sides, so 3x equals 150. And that is by the subtraction property of equality. And so then our 7th and final step, divide both sides by 3, so x equals 50 by the division property of equality. So there we go. Are there questions? On the back side of your notes, there are a few more properties just to talk about quickly. Okay? These are very similar to the properties of the same name, but of equality. These are all properties of congruence. Okay? So the reflexive property basically saying, hey, if you have angle A, then angle A is equal to angle, or congruent to angle A. Symmetric property, same thing as it did before. If angle A is congruent to angle B, then we know that angle B is congruent to angle A. We're just flipping them around. The transitive property is a great one, though. And these are three different examples of the transitive property. I'm just going to look at this middle one. If we know that angle A is congruent to angle B, and we know that angle B is congruent to angle C, the transitive property allows us to skip the middleman. Skip the middleman. We know that angle A is then congruent to angle C. Okay, that's what the transitive property allows us to do. We have to know two statements so we can then say the third. All right? So we'll come back to those properties again tomorrow. Let's take a look and see if we can get through one proof before we leave for lunch. So taking a look at this proof here, writing a two-column proof dealing with our angles. First thing you want to do before you ever start your two-column proof is you want to look at what the heck are they giving you and what the heck are they asking you to prove. Okay? So looking at the diagram here, they say that angle 1 is congruent to angle 3, or actually they say the measure of angle 1 equals the measure of angle 3, right? And they have that marked in the diagram as congruent. But they want us to prove that the measure of angle AEC equals the measure of angle DEB. So we've got to identify what those two angles are. So angle AEC, I'll call that the red angle here. And then angle DEB is this blue angle here. So, looking at that, is there any idea, anybody have any ideas on how we might go about showing that those two angles, the red angle and the blue angle, are the same measure? So, we have discussed how these angles come about. We know that these angles are coming about from adding two angles together. Okay? So, here's my statements. Here's my reason. Please write this down. Don't just sit there and watch. Write this down. I'm going to go quick. So, statement number 1 is our given. We know the measure of angle 1 equals the measure of angle 3. Well, I want to prove something about the measure of angle AEC. So I'm going to go ahead and start talking about angle AEC. So my second statement, I'm going to say that if I take the measure of angle 1 and I add to it the measure of angle 2, I get the measure of angle AEC. I know that using what postulate? The angle addition postulate. I can do the same thing for our blue angle up there. The measure of angle 3 plus the measure of angle 2 is going to equal the measure of angle DEB. Okay, well, I want an equation that somehow shows that these two angles are equal to each other. Okay, they're involved with each other. Well, I do have an equation that says the measure of angle 1 equals the measure of angle 2. Or, I'm sorry, the measure of angle 3. And I have the measure of angle 1 sitting right there. And I have the measure of angle 3 sitting right there. I know those angles are equal. So what if I subtract the measure of angle 2 from both sides? I'm going to do two steps in one in my proof here. If I subtract the measure of angle 2, I get an equation that says the measure of angle 1 equals the measure of angle AEC minus the measure of angle 2. And I can do the same thing for the measure of angle 3. I get the measure of angle DEB minus the measure of angle 2. I did that by the subtraction property of equality. So now I can set this equal to this using that first step in our proof, that given equation. So I know the measure of angle AEC minus the measure of angle 2 equals the measure of angle DEB minus the measure of angle 2. By substitution, I'm almost done, so please sit tight. And now if I add on the measure of angle 2 to both sides, I get the measure of angle AEC equals the measure of angle DEB using the addition property of equality. So there's our completed proof. Your assignment for me today